Hello everybody, welcome to my another video in which I try to explain physics as simply as possible but not simpler. In my previous videos I explained to you the uniform motion. Please check it here or in the description of this video. So in uniform motion the speed was constant. You were all the time moving with the same speed. But this is not always the case. What is more, it's rarely the case. I mean, most often you are not moving with constant speed, but you are accelerating or decelerating, which means your speed increases or decreases. So, for example, you accelerate when you start driving your car or bicycle, or when you just increase its speed, and you decelerate when you slow down before the red traffic lights or before you get to your destination. So in physics we describe the nature, the reality quantitatively, which means we use numbers. So we need another quantity to describe this situation, and this quantity is called acceleration. Okay. How to define this acceleration? Okay, let's think of an example. You have two vehicles. First, it's super fast Porsche or Ferrari car, which can accelerate from 0 to 80 kilometers per hour in 4 seconds, let's say. And on the other hand, you have a big truck, which is not so super fast, but it also can accelerate from 0 to 80 kilometers per hour. So what's the difference between them? As I said, the Ferrari can accelerate to 80 kilometers per hour very quickly in say 4 seconds, whereas the truck needs much more time, for example 20 seconds or maybe a minute to reach the same speed. So this brings us to definition of the acceleration. So not only the change in speed matters, but also time in which this change happened. Okay, so acceleration is denoted by A as acceleration, no surprise. So it equals to change in speed divided by time. Okay, this triangle is a Greek capital letter delta, and in physics, if it's before something, it means change in this something. So delta v means change in v, so change in velocity. So change in speed means new speed minus old speed. So for example, new speed 80 kilometers per hour minus old speed 0 kilometers per hour. So then change in speed is 80 minus 0, so it's 80 kilometers per hour change. And this is time. So acceleration is change in speed divided by time. Okay, we will focus on the uniformly accelerated motion, which means that acceleration is constant. Acceleration doesn't change. This will simplify our calculations, but it doesn't have to be the case. Actually, often the acceleration is not constant because, for example, if you start driving your car or bicycle or electric scooter, you know that initially it's easy to accelerate by, say, 20 kilometers per hour, but when you get closer to maximum speed of the vehicle, it takes more and more time to increase your speed. That's because of also because air resistance, but not only. Okay, but we will focus on the case of constant accelerations, so the so-called uniformly accelerated motion. It's also, we should also discuss what are the units of acceleration. So in the SI system, units of acceleration, well, speed is in meters per second, so change in speed is meters per second, and you divide by time, which is also in seconds. So this is like meters per second divided by seconds. Second is like second over 1. So if you divide the fractions, you multiply by the inverse of the second one. So it's meters per second times 1 over s. So it's meters times 1 meters. Second times second is second square, like 5 times 5, it's 5 squared. So the unit of acceleration is meter over second squared. Okay, now it's a good moment to see an example how to calculate the acceleration for a particular case of some car. So I invite you to see this in my next video.